bracket. This is 1.6b part 2. And we're going to do practice problem number 4. Okay. There's a couple of things I want to go over before we actually do the problem. Let's talk a little bit about the symbolization here, okay? So for the symbols here that we've been working with for the past few days, I want to just generalize what's been going on. If we have a less than, greater than, in Algebra 2, we're using parentheses for interval notation, okay, and for graphing our lines on a number line. Now, for the past 3 years, maybe even 4, you guys have been using these open circles and then graphing a line from there. Why we teach you that in mathematics, I don't know, because from Algebra 2 on, you'll never see these circles again. I don't know why we don't just start from the beginning teaching you with the parentheses and brackets. Speaking of brackets, if I have a less than or equal to, a greater than or equal to, that's when we use the brackets to include that endpoint. Now, in Algebra 1 and pre-algebra and stuff, you probably used to a closed circle or what looks like a point. So those are the symbols we've been using, I know, for 1.5 and 1.6. Okay. Now, let's go over just a couple of like definitions for 1.6. Okay. This time, I'm going to group these a little different. I'm going to group these with my less than signs here and the less than or equal sign. And when I'm dealing with inequalities with absolute values, so this is for 1.6. When I have less than or equal to, I am going to use the conjunction word and. If I have a greater than or a greater than equal, I'm going to use the conjunction word or. Okay, so here's a couple of definitions for 1 point that are specific for 1.6. Now, I think I went over these in 1.5, but 1.6, you're going to be using these all the time. There's a catch to this, okay? Before you can apply or split up in 1.6 part 1, you split up that absolute value equation. Now, before you do that with inequalities, you're going to have to, let's see, you have to get the absolute value term. By itself first. Or what we call isolated. Okay. Before you split the problem up. Or in other words, can't make my U's. Or in other words, choose between and or. Okay. Choose the conjunction word. Now, it's really important that you guys do this because there's going to be problems, and I don't like some of these problems that they gave you because some of them are there just to trick you up. Okay, but this is really important. And I'll tell you why. Okay, let's look at problem number, I think it was problem number 2. Okay. Problem number 2 said, I have the absolute value of negative 5v less than or equal to negative 20. Now, normally we would just split this up, and set one to the opposite of there, flip the sign. This is an and statement, and so on and so forth. However, if it's because that is isolated that I can do that right away. Suppose I had like a negative 2 in front of here. That's being multiplied by our absolute value. So I would have to get my absolute value symbols. I should put symbols up here, not just the term. I have to isolate those symbols. Therefore, I would have to divide both sides. There's multiplication between the negative 2 and the absolute value symbol. I would have to divide, think of it as a coefficient, by that negative 2. Well, that's fine. That's great. I get my absolute value of negative 5v. And here I get negative 20 divided by negative 2 is 10. But look what happened here. Okay, I divided by a negative number. So I would have to flip that inequality sign. If I didn't get the absolute values by itself, I would have started and made it an and problem because it's less than or equal to. Less than or equal to is an and problem. But I went ahead and switched it because I divided by that negative number. This became an or problem. Then separate it. Okay. Really important to make sure that you get the absolute symbols by themselves. All right, so let's go ahead and do, that was just an example. It's not any particular problem. Let's go ahead and go back to problem number 4 here. So problem number 4 in your practice packet is, I have the absolute value of 3x minus 7 is less than negative 16. Okay, I'm good here. My absolute value symbols are isolated. There's nothing being multiplied, added, or subtracted. Sometimes they'll add a number or subtract a number. So I can go ahead and split it up. Take what's inside. Now, this is a less than problem. Less than is an and problem. Okay, so I take what's inside, 3x minus 7. And I'm just going to keep everything the same here because I like my negatives on the left side. So I'm just going to keep everything the same. It's an and problem. Take what's inside, 3x minus 7, and multiply that or divide it by negative 1, however you want to think about it. So now I get a positive 16. But since I multiplied it by negative 1, I have to flip that inequality sign. Now I go ahead and solve these. Solve for x. Okay. Add 7 to both sides. I get 3x less than negative 16 plus 7, negative 9. I missed a negative sign, didn't I? There should be a negative. This should be a negative. That should be a negative. That should be a negative. Okay, sorry about that. So now I have to divide by -3. And I get my x. I divided by a negative number. So I have to flip the sign. -9 divided by -3 is 3. It's an and statement that doesn't change. +7 plus 7. I get -3x greater than 23. Divide by -3. Divide by -3. And I get x flip -23/3. Okay. Now, we have to draw a graph. And if you remember, and problems, so I'm going to add some more stuff over here on the side. And the problems, their graphs look like either a parenthesis or bracket, in between. Or problems look like both ors. So they're going to go towards the outside 99% of the time. Okay. Out towards infinity. Interval notations, well, the ands just follow either bracket or parenthesis, this number, comma, parenthesis or bracket, that number. Ors are a little more tricky, okay? Ors is going to be -infinity, comma, number, parenthesis or bracket, union, parenthesis or bracket, comma, positive infinity with a parenthesis. Those are graphs for and or. But let's go back to our problem here. I have an and problem. So it's going to be an in between. It has to be this. So my numbers here, let's see, this one's negative, that one's positive. So automatically this one's bigger than that one. I have -23/3, 3. I know it has to be in between. And no equal sign, so they have to be parentheses. Now, this is why I don't like this particular problem or these little tricks that these that this book throws on you guys. Normally, you would just go here and say, "Oh, okay, well, you know, interval notation. I have parenthesis -23/3, comma 3, and another parenthesis. There's my interval notation." But this is a trick problem. Because what this says is, well, my x has to be greater than 3 and less than -23/3. But it's an and problem. It can't go opposite ways. So let's just take a number here. 0. That's supposed to be a solution. Is 0 greater than 3? Well, no. Is 0 less than -23/3? No. So how it can't satisfy both statements at the same time if it doesn't have this graph. So in this situation, guess what they did to us? There is no solution. So they kind of threw in a tricky problem in there right off in number 4. And I don't like it because it's so rare that something like this happens. Okay. If you guys went through all the whole problem and got this answer, I would probably just note it somewhere and say, hey, this is really a no solution because it doesn't work for both inequalities, but I wouldn't take off any points. Questions, comments, concerns? Do you see how detailed this whole thing is? I mean, there's a lot of stuff going on for one problem. All these things you have to remember to solve one absolute value inequality. So be careful with these. Take your time. They are not the easiest. Well, they're not hard. It's just that they're extremely detailed. If you have any questions or problems, please stick around. I will make a video, post this video once it gets all uploaded and stuff. Okay? If you have any problems, feel free to